Welcome to the session. Greeting of the day. In the previous classes we have talked about in the arc welding process, this is shielded metal arc welding we have done. It means nothing but a manual metal arc welding process. In MIG welding setup, we can see the welding power sources and the cables, welding tabs, wire feed mechanisms, shielding gas cylinders, and control system for on and off. What is it is available? See the setup here. We have the spool. We have the spool here. We have the spool through which the filler wire electrode can come. See, here the electrode can come here. And therefore, here this is the controller, roll straightener. So this rollers are straightening rollers. And then we have the setup of machine, and the supply comes here. See the supply positive, and here we have connected up to a DC electrode positive. Why this is positive here? Because filler wire is consumable. So that filler wire should comes down and weld. So this is a simple arrangement. The gun, spool, power source, and the feeding mechanisms. So welding power sources, welding torch. Now only the torch we have seen. The welding torch, this gun, and then the wire feed mechanisms, wire feed spool and the wire feed mechanisms, how to roll, and then shielding gas cylinders. What we are giving here? We are supplying maybe the argon, maybe the helium, maybe the CO2 active gases. So this is MAG. So this is MIG welding process. So such things we can able to do here. So simple arrangement, consumable electrodes. So you see here we are using a connecting of power sources in DC electrode positive. How we are doing here? So we want to consumable electrode we are using. Consumable electrode we are using. Therefore, it should be melted and deposited. Right? We understand. Therefore, what happens there when we are connecting this same setup here? So I am connecting the positive here and the negative to the workpiece. What happens? This electron flow takes place from the workpiece to the positive end, opposite to the negative, to the opposite, to the positive end. Where is the positive? Positive is connected to the consumable. Then the heat is generated at the positive. Therefore, we can tell heat generation at the positive. Heat generation at positive. Therefore, this positive end will get this positive end. This positive end will be electrons will be attracted. High heat point. This is the high heat point. And then it receives, then melts, and then deposited, and we can able to welding can be completed. What are they available here? We have the copper nozzle, electrode solid core wire, not the fluxed wire, core wire. So it is a driver roll. From there it comes, from there it comes here, from there. And then the shielding, this blue color is given for the shielding. You have to give separate plugins are there. So shielding along with the shielding, and this region is protected. This region is protected from the atmospheric contaminations. So the consumables, what we are using, consist of wire and gas, the same quality for the TIG wires also. The wires are copper coated. Why we are doing the copper coated? As to main purpose of corrosion resistance to be there. Earlier in the shielded metal arc welding process, the bare wires or electrode wires are covered by the flux coatings that protects this electrode from the atmospheric contaminations, and when it comes out to weld to the base material, the shielding flux which is generated by the heat also protects from the contaminations. But here, where there is no flux covering, therefore we are giving the copper coatings over the bare wire. Therefore the copper coated is useful for corrosion resistance. And also the electrical pickup. So the arc, striking of arc gap, stability of arc to be there. Therefore this copper is good conducting. So therefore it can be used for the electrical pickup also. The wires are available in the various sizes of, as I told you, 0.6 to 1.6 mm. Bare wire, flux is not there, only 1.6. It is to be feeded in this gun. So it is to be feeded here. So it is 1.6. It is 1.6 mm. Okay. See, most wires are supplied on 15 kg spool, the total weightage, and then the gases can be poured as a CO2 or CO2 plus argon. We are mixing them. The active gases, inert gases are mixed, and argon plus 2% of O2 mixes also are done. Okay, so principles how we are doing. Proper current and wire speed is tested because it is automatic. The current setups and then wire speed, how many spool, how many speed it should come in, what meter per second it should come out, what mm per second should come out, that to be fed to the machine setup. Before starting the welding, before starting of the welding, these things we have to check, because the shielding to be done before the starting. If it is started, heat generated, automatic atmospheric contaminations will come into the picture. Therefore, before starting of the welding, these all things to be done. What we are doing? Shielding gas open, water cooling the gun, the torch. It is a water cooling torch. It is to be on because heat is going to be generated in the gun also. Optimize the current. How much it is? Maybe the 120 amps. How much we have to keep? Those fixed values are keeping there. And welding started at any of method. What we are doing is we have seen already. Maybe a touch start method or maybe the field start method. Anything we can able to do, and whether we can able to touch and maintain. And then otherwise field start. Field start is we can do for automatic. Semi-automatic we are touching. Little bit touching method we are doing the semi-automatic or manuals. So automatic field start we can do. Pushing up high what is applied and then the arc generated, and this 1 mm or 2 mm is 3 mm is maintained in between the base material and the consumable bare electrode. Consumable bare means it keep on melting and depositing. At the same time spool rolls. Same time it comes down. During welding the torch remains 10 to 12 mm. How much it is? 1 centimeters. 10 to 12 mm. Small gap to be maintained away from the workpieces. So we are maintaining the gap. This arc length gap. Arc length. Arc length is kept between the maintaining of 1.5 to 4 mm. This process based on the principle of developing the weld by melting of fairing surfaces by the base metal using heat produced by a welding of arc established between metal and the consumable electrode. This point I have told you in the diagram itself. The welding arc and the weld pools are well protected by the jet of shielding inert gases coming out from the nozzle and forms the shielding. So this is the MIG welding principles. You see, we know MIG welding, the consumable filler wire. The consumable filler wire we are supplying at the center. Side by side we are supplying the inert gases. For MIG we are supplying the maybe argon, helium. For MAG we are supplying the active gas of CO2. So maybe this blue color is maybe the argon, maybe the CO2, depending upon the MIG and the MAG welding process. On the same gun, consumable electrode, shielding gas. Shielding gas is supplied earlier, pre-flow, post-flow. Those things are supplied here and welding has been completed accordingly. Principle again. Difference in cleanliness of the weld produced by the MIG welding and the TIG welding are primarily attracted by the variations in the effectiveness of the shielding gas. How? If the shielding is not sufficiently given, the cylinder is not opened proper, then shielding is not supplied the sufficient amount. Then what happens? Shielding is not proper, means automatically contaminations, automatically hydrogen embrittlements, automatically the porosities, defects will form. So sufficiently we should provide. That is the amount. Power sources, we can use the constant voltage, we are fixing 24 volt, or constant current, we are fixing 130 amp. And then we are running the automatic systems. Automatic. Selection of power source. How we are selecting this 24 volt, 130 amps? Based upon the electrode diameter. If the electrode diameter is increasing, the current should increase. So based upon the diameter, we are using the 0.6 to 1.6 mm. So for this it is 130 amps we can able to use. So based upon the material, whether it is hard material or ductile material, so based upon the material also we can at the less current aluminum, it is melting at a low temperature. Therefore we should give current less because it absorbs heat. More heat is not required. On such cases we are comparing and specifying after experiments we are doing fixing. So electro extensions also required. How much it is we are seeing. In case of small diameter, that is less than 2.4 mm, electronic resistance heating control the melting rate. Constant voltage power source of DC electrode positive, we are using direct current electrode positive. Now, just now I have told you here the diagram, direct current electrode positive, what we are using here. This positive consumable electrode to receive heat and melt and falls down. So such cases are there. Operating variables. What are the operating variables are there here? The welding bead shape, depth of penetration and overall weld quality depends on these operating variables of welding current, polarity, arc voltage, welding speed, length, electrode diameter, shielding gas, gas flow rate, wire feed. Important topic here. See, if the current, whether it increase or decrease. If the current increases, penetration increases. It depends on penetration. Polarity, whether may be a direct electrode positive or direct current electrode negative. Which one we are using? We are using the positive. Arc voltage, how much width? Increase or decrease in width? Welding speed. Welding speed decides the both penetration and width. Because when we are going at a high speed, melting won't occur. So melting, it is a melting won't occur. Heat generation, we have to slowly, optimally, we have to heat the filler wire, heat the base material failing surfaces and it should be deposited. Without depositing, going very fastly, what is the use there? So welding speed is the most important factor as like current and voltage and polarity. Each parameter reduces their role importantly. So length of striking out. What is this length of strike out? Arc length to be maintained. So this arc length. Where is this arc length? We have seen this arc length is nothing but the gun, the workpiece to be welded. This gap, you see, this gap
known as strikeout length.
This is a nozzle. We have the filler wire here. It comes like this. It keeps on coming, and here it should hit. Here it generated the arc. Here generated the arc length here. This strikeout we should do. Right? Likewise. So length of strikeout, electrode diameter. How much diameter we are using? From the 0.6 to 1.6 mm. It is based on reflect on the current also. If you are using low current and large diameter, what happens? It takes more time to melt. But we are going melting speed high. What happens? It won't melt. Therefore, this reflects in current, voltage, speed. All things to be changed when this diameter is changed. Interrelated. These are interrelated here. Current, polarity, voltage, speed are interrelated. Shielding gas. For what we are using the shielding gas here? For protection. Protection from the atmosphere. Gas flow rate sufficiently to be given, or otherwise also open shielding gas we are giving. Okay, I am satisfied. It is not like that. You should give sufficient flow rate. 15 liters per minute. 15 liters per minute. Likewise, we have to give appropriate level. Level of shielding. And then the wire feed speed. You see, this is also speed rate. Speed of wire feeding. See, as usual, we have the spool here, we have the gun here, and it comes out, and we have the weldings here. But it comes from here. At what speed it comes? It cannot keep on rolling at 10 meters per second. Wrong. If it comes out, it is going to hit here. If the filler wire comes and hit here, it is a shut off. Arc to be generated in between this. So arc to be generated here. Arc to be generated. So approximately it should come accordingly with respect to the exit, according with respect to heat generation, according with respect to melting and depositing. If it is not melted, if the wire comes here, what happens? This wire will hit here and turns like this. Or otherwise, it will melt high because heat is already generated here. It will melt high and it will deposit more filler wire here. It will deposit more filler wire than that of the sufficient. It will deposit more filler wire. If the heat is not sufficient, filler wire will not melt due to the excess of roller comes in and goes that side. Otherwise, if the heat is high, when the roller comes in, it melts and the welding depositing will make here. Higher deposition. This is called as reinforcement. This is called as reinforcement. So high reinforcement is not required. We need maximum reinforcement of 1 mm to 1.5 mm. 1 to 1.5 mm reinforcement is okay. Greater than this is not okay. Okay, so 1 to 1.5 mm reinforcement only. How much reinforcement then? This is the reinforcement. How much? We need only this level. This level of reinforcement is okay. See, this level of reinforcement is okay. Why need to go there? Then the speed, this is to be maintained. This speed to be importantly controlled. Based upon the heat generation, based upon the arc length and the gaps, we should maintain these things. Very important topic. So wire feed speed also, importantly, we should maintain. All parameters are important in their factor. Shielding gas important, polarity important, current important, speed important, voltage important, polarity, everything, diameter. If the diameter, only single diameter is changing, we are keeping all other things constant. What happens? High diameter, current not sufficient, will not melt. So obviously the cavity will be there. If the welding is not there, V groove is not filled. So that all these are interrelated contents. Now we come to one by one. Polarity and MIG, direct current electropositive is preferred due to stable arc and then smooth metal transfer. Yes, we can use the smooth metal transfer and also less spatter. Arc is maintained here. High current is not there. Properly maintained. Then what happens? There is no possibility of spattering of melted material. Actually, it is depositing in the V groove. There's no need of spatter there. Good weld speed over the wide range of welding current. Right. Now, I'm increasing the current. What happens? We'll see. If the increasing current happens, it increases the depth of penetration. Yes, we are making the flow of current increasing. Current increase, penetration increase, voltage increase, width increase. This we know. So therefore, I'm just remembering here. Increasing the current increases the depth of penetration and increases the deposition rate also, because increasing the current increases the heat. Increases the heat also. Therefore, increasing current gives these two options. Increasing depth of penetration, increasing the deposition. Both are good. But depth of deposition rate to be up to V only, here only. If high reinforcement is there, it is not good. Reinforcement to be kept within 1 to 1.5 mm. So up to that it is good. Why I am not using the DCEN electrode negative in shielded metal arc welding or in MIG welding process? Because the consumable electrode to be received the positive end to receive heat, therefore negative to by the principle, electron moves from negative to positive, electron having less denser, and therefore it can move with a high velocity. Therefore, moving of high velocity creates the heat energy. That heat energy is absorbed by the consumable electrode and is melted and comes down. But when we are using for these cases of consumable electrode DCEN, what happens? Heat is generated at the workpiece. But we have to melt the electrode. So, negative end having the less heat, positive end of workpiece having the high heat, there is no use of melting. Melting will not occur. So, unstable arc will be generated. The other points, unstable arc, sometimes short circuiting will be happen. Lower penetration. Why it is lower penetration? Because this filler wire is not melted. Obviously, falling down is also less. Fluidity will also less. Therefore, low penetration will happen here. Higher melting rate of the electrode. So, this is all things will happen. Alternating current not preferred as arc extinguishing in the erratic form, and also alternating current finds the welding of the aluminium. So, what we are using aluminium is a less melting point. So we don't need to use the direct current here. In these cases, we can able to use the alternating current. But therefore, what happens? The flow takes place in the both sides. It means the electrode and the workpieces. So it goes here, melts the aluminium. It goes here, melts the electrode. Both melted and deposited, and it can be deposited here. So such cases are possible by the direct current electronegative. You see, this welding current, when the current increases, penetrations also is keep on increasing. Current also keep on increasing. See, the electron flow positive, direct current electrode positive, direct current electrode negative. Flow takes place reversely. The MIG process is variables, arc voltages, travel speed. See, when the travel speed is increasing, obviously the deposition is decreasing. See, from here it is deposited is decreasing. See, deposited is decreasing here. From here is more deposited, less deposited, less deposited, less deposited. Travel speed increasing. Obviously, arc voltage increase, width increase. See, voltage increasing, voltage increase, width increase. With increase, increasing the width. So here the electrode orientations I am telling that I am doing this like this welding or vertical welding, or can be the leading process can be done. In the vertical trailing, we are keeping away the welding process. Welding is done from this side to this side. What happens is the penetration can be increased. When doing the vertical process, a similar pattern are done. But when doing for the leading edges, like this when we are doing, our hands are also getting heated. welding is done here and I'm traveling over there, the welder faces some difficulty due to this heat also. Therefore, we should come away from the welding. So such cases are done. See, when it is traveling away from the welding, here the penetration also is increased. When it is leading towards the welding direction, he is going in this way. Heat is absorbed by the gun and the welder hands. So the efficiency are decreased here. Penetration is shallow. Excess weld metals are minimum. Undercut also minimum. Now we come next to the shielding gases. As of now, we have seen about the polarity. Now we are seeing about the shielding gas. So why we are giving the shielding gas? What it affects shielding gas and its flow rate. See, I have taken two words here. These words we have seen here. We have seen here the shielding gas and the flow rate. So the shielding gas and flow rate have the effect on where it affects their arc characteristics, then the mode of metal transfer. If shielding is proper, the outside air force will not affect here. Somehow the air fluctuations will not be there. Therefore, the mode of metal transfer from the electrode to the workpiece will be steady state. A globular transfer or short circuit will be in the steady state way. The penetrations, shielding increases, also the penetration depends. Width of the fusion, whether the penetration or width, how far it is, will be increasing or decreasing. Speed of the welding. If the shielding is there, high heat can also be generated at those specific plasma zone. Therefore, welding can be done. Here, high heat generated, we have welded and deposited, and we can continue welding at a high speed. And quality of the weld can be improved. Quality of the weld can be improved here. And elemental transfers, alloying systems can be done. And mechanical properties also, it affects. Maybe the cracking properties, toughness, tensile property can also, it affects. Based upon the how flow rate we are given. So we have to see two terms of inert gas and the active gas. Here, when we are using the inert gas, we have told you it is MIG welding process. When we are using the active gas, I told you it is a metal active gas process. Active gas welding. Active gas welding process. So inert gas has no effect, this word is important, no effect on final weld. It is just like outer covering. It will not affect the inner heat or otherwise this defect concerns or otherwise the chemical reactions between this consumables and the gases. There is no effort. But it is just to protect from the outer contaminated airs and merely protects the arc from oxygen and contaminations in the air environment outside atmospheres. So due to their complete valence shell, inert gas have their low reactive compared to the other gases in the periodic table. So it is not reactive. That is known as inert gas, not active gas. So it is known as reactive gas. Low reactions will not be there between the air and these particles of the inert gases. So what are the inert gases available? We are using like helium, neon, argon, krypton, xenon are used for the shielding. Okay. Now active gas, it makes the reaction in between this base material, this heat, this filler wire, it makes the reaction there. And due to those reactions also heat increasing may takes place. Otherwise some other benefits will be there for the penetrations. So such cases, active gas adds slight electrical conductivity and breaks down, this is one point, breaks down the weldable surface tension for better penetration. See, for better penetration of the welds. Active gas, what we are using? Nitrogen, hydrogen, oxygen, CO2s are used in the active sites. So we can do this combination also. This argon of 80%, of 100%, so and remaining of 20% of CO2. Like combination of shielding gas can also be given. So 80% it is not affected. Remaining 20% we are doing for this two reactions, electrical conductivity and also the surface tension, to increase the better penetrations. So this is protection plus penetration we are getting. So likewise combination we can able to use. Not only the argon, it may be the helium, it may be the neon, it may be the krypton we can use. Here not only the CO2, we can use this oxygens and the nitrogens also. We came to the advantage and the disadvantages. See, because of continuous feeding of the electrode, what happens? As in the MIG welding process, comparatively to the shielded metal arc welding, we are supplying the continuous roller there. Therefore, due to continuous roller, there is no stop problem will not be there. So that is one advantage. Much faster as compared to the TIG welding and SMAW. These are all manual. This 40 centimeter, I told you, 450 mm electrode to be changed at every time it is consumed. But here it comes in the roller. Therefore, it is continuous. This start-stop problem will not be there, and you can go much faster. It means work efficiency can increase. Out of 8 hours of duty time, 8 hours of running of the machine, efficiency is increased in this MIG welding process until the spool is completed. Right? So that is how we can understand. Reducing the number of start-stop problems. Start and stop. This is, see, in manual, each start and stop for every 450 mm of electrode. But here it is not there. It is just because it is continuous. Weld almost all commercial welding of metals and alloy system can be done with respect to the corresponding electrode. With respect to the corresponding electrode. Wire is about 1.6 mm. So therefore, as it is a shielding gas, there is no dry fluxes like submerged arc welding. We can use in the all positions. We can use this in the all positions. Very good. 1G, 2G, 3G, inclined and overhead 6G. All positions can be welded. Significant higher deposition rate. When we are using compared to this one, deposition rate also high. Continuous process. Good shielding. Automatic machine setups. Semi-automatic and automatic machine setups. Melting, depositing, moving. Melting, depositing, moving. So, when compared to the time, deposition rate is high for the duration of 8 hours of duty time. So, likewise we can compare. Deposition rate is high. Higher welding speed than that of SMAW and TIG. Obviously, as it is automatic, welding speed is high. No need to change. Okay, and also it is not manual, automatic. We are keeping arc length perfect. We are keeping the voltage perfect. We are keeping the current perfect. Welding speed, feed rate, all things we have given. Why there is no need to delay. So welding speed is high as compared to the manual. Here you have to keep at center to the shielding. You have to see the center point and we have to weld. In the meanwhile, our hands movement is welder skill is needed. Here there is no need of skill. Machine is going to do the welding. We have to go into set. That's it. And it will do automatically. Semi-automatic also are there by manual gun operations and also machine setups also available. So what is the then limitations here? Even this as automatic it become extensive, expensive, hard to reach places with the MIG torch as in the SMAW holder. So here the machine cannot go at every places to all the corners. All the corners cannot go. In case I want to weld those corners, this gun and cannot go there, the machine setup. So the manual electrode to be taken and you have to weld it to the corners. So therefore, hard to reach the places with the MIG torches, metal inert gas torches, than that of shielded metal arc welding holder. So manually, we can go to those corners and we can weld. That difficulty is there. For proper shielding torch close to the joint with 1 to 15 mm, cooling rates are higher. Very important point. You see, here in the shielded metal arc welding or in the submerged arc welding process, we have used the fluxes, external fluxes which act as a protective layer from the atmospheric contamination. That is one advantage. And also second one is it acts as a protection to avoid the cooling rate. It keeps the weld metal warmer and slow cooling and act as a annealing treatment also. But here there is no flux. Whenever it is welding completed, it is directly exposed to the environment. The welding, until welding completed, we are giving the shielding. Shielding protection is done from the atmospheric contaminations. That's okay. When the welding is completed, we are removing the shielding and it's exposed to the atmospheric. Therefore, immediately due to the temperature gradient, this transaction of temperature occurs and cooling rate will be faster. If the cooling rate is faster, chances of martensite, chances of brittleness on the alloying systems or on the metals will come. We may not achieve the ductile property of the material. So some protections to be given from the atmospheric for the cool down, or that is further after this MIG welding process we have to go for the heat treatment to improve the property of the metals. Such cases are to be happened here. Very important point. Cooling rate is higher. Cooling rate is higher here. But in the SMAW and some jack welding, cooling rate is slow because the flux protection is there. Air draft may occur in the order to the environment also. Proper closed protection is needed. What is the simple point? Air draft may occur. We are doing the machine welding here in this open space of dry city or in the Dubai. Let us consider. Not in the industry. Outside the industry we are doing. Outdoor environment we are doing the welding. In the outdoor environment we are doing the welding. Heavy cyclones or heavy air is there. We cannot able to weld. Because the shielding we are giving, it will fluctuate. By through the cylinder, argon shielding, CO2 shielding, the mixture of argon and CO2 we are giving. But this mixing gases also the gas. It fluctuates along with the outer air. If the outdoor air is not proper and very fast velocity it is there, storm is there, then we can't able to weld. A closed environment with a stable space is needed to do this MIG welding process. In such a way, the shielding gases will protect it perfectly. But in the case of electrode, we are not using those things. There are also those problems are there, but compared to this, they are lighter. Because in the submerged jack welding process, heavy fluxes covered the electrode. It is solid, but it is a gas. Where in the stems of MIG welding, there is no fluxes. Solid fluxes are not there. Therefore, here in this MIG welding process, air draft may occur in the outdoor environment. So, proper closed protection is needed. So, some closed box like setup or not box like setup, room like setup is needed to covering the welding process. So, these are the various disadvantages and advantages to keep importantly for MIG welding, metal inert gas welding methods. So now coming to the applications, I have already told you we can be able to weld. It can be able to weld this all parts. Almost all commercial metals are possible. So that is what I am telling here. We can able to weld carbon steel and stainless steels, aluminum and alloys, magnesium and its alloys, copper, nickel, titanium, aircraft parts we can able to do, pressure vessels, shipbuilding industries, everywhere we can able to do this commercial welding can be done.
Somewhere right in here. So I'll get my hand set like this. And the nice thing about these auto dim helmets is I can flip my helmet down before we even start. So Joe, just let me know when you're ready and we'll run a weld here. Alright. So I'm doing circles here. So we were backstepping into the piece doing the little circles. That's one way that you can do it. Second way we'll do below, I'll show you how to do the letter C's. So I'm going to do one over here. Try and get a good spot weld, a couple good spot welds I'll do for you, and then I'll change the machine and let you see what an incorrectly set up would look like. So let me know when you're ready, Joe. I'll do three in a row. So those ones there, they're not too bad. See if I can hold the piece up for the camera so you can kind of see. Hopefully you guys can see. They're pretty flat. They're not sticking up way above the workpiece here, above the metal. They're laid out pretty flat.
What is MIG welding? MIG stands for Metal Inert Gas Welding. The American Welding Society calls this process gas metal arc welding, or GMAW. You might also hear it called wire welding. In MIG welding, a thin wire acts as the electrode. This wire is fed from a spool mounted on a gun or inside the welding machine through a flexible tube and out of the nozzle on the welding gun or torch. The wire is fed continuously when the trigger on the welding gun is pulled. When this trigger is pulled, it also switches on the welding current and a shielding gas. An electric arc forms between this wire electrode and the workpiece and heats both metals above their melting point. These metals mix together or coalesce and solidify to join the workpieces into a single piece. The metal in these parts to be joined is called the base metal, and the metal that comes from the melting wire electrode is called filler metal. MIG welding always adds filler metal to the joint. Because the wire electrode melts as it's being used, MIG is called a consumable electrode process. Here's the MIG wire going through the wire feeder into a flexible tube or conduit liner. The liner goes through the hose or welding lead all the way to the torch nozzle. At the nozzle, the wire is fed through a contact tip and comes out at the point of the weld. Shielding gas is also fed through the welding lead. It goes through a gas diffuser and flows out of the nozzle. This shielding gas, which is often a mix of argon and CO2, protects the molten metal from reacting with oxygen, water vapor, and other things in the atmosphere. The shielding gas is stored in high-pressure cylinders like these. The pressure is reduced to a usable level by a device called a regulator. In MIG welding, all the machine controls are set on the machine itself. The most important of these are polarity, wire speed, and voltage. The trigger on the gun is just an on-off switch. For most MIG welding, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always the negative, and one is always positive. In DC MIG welding, the electrode is usually positive and the workpiece is negative. The term DCEP is used, indicating that the current is direct current and the electrode is positive. This is also called reverse polarity, but DCEP is a more descriptive term. In an electric circuit, the current flows in a loop. In MIG welding, the current has to flow in a complete circle from the machine to the torch, into the work, and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. So, in summary, MIG welding is an electric arc welding process. It uses a consumable wire electrode. Filler metal is added automatically, and the shielding gas comes from a high-pressure cylinder.
Summary: in welding, we have seen today about the MIG welding process. In case also MAG welding process. When we are using the inert gases like argon, it will become MIG. When we are using the CO2, otherwise active gases, it will become MAG welding process. And also we have seen the various parameters of effort and the advantages, disadvantages, and applications. We have used in this MIG welding process this direct current, electrode, positive we have used. The remaining part of the subjects we will see you in the next session. Thank you.